The spiral machine is used to produce spirals for use in spiral screens. Round monofilaments made from various plastics of various widths are used as source material, for example PET, PPS, PA, etc. In the following, monofilaments are also described as thread and spiral wire. The spiral machine essentially consists of two spindles that function independently of one another. Thanks to that, it is possible to wind simultaneously left and right spirals. Please notice that spirals can only be produced by using round monofilaments. The explanations of the terms below are listed in the order of the monofilament or spiral flow, respectively from bottom to top. All monofilaments are processed on a K335 spool. Depending on the wire profile and wire diameter, the maximum winding of the coil is between 2.5 kilograms and 25 kilograms. The tangential unwinder serves the uptake of the coil. During the winding process, it guides the spiral wire from the coil through the various guides and rollers to the spiral preheater. Working with the wire tension sensor, it also ensures consistent, uniform tension of the spiral wire. In other words, the tangential unwinder also acts as a brake. By default, tangential unwinders use K335 coils, with up to 10 kilograms of winding. With appropriate design, 2.5 kilogram coils and 25 kilogram coils can also be used. The spiral wire is preheated in the spiral preheater. The temperature is set, monitored and controlled using the controls depending on the material to be processed. After exiting the preheater, the thread continues onto the thread tension sensors. Using the thread tension sensors, the controls constantly adjust the current thread tension with the parameter values specified in the controls, and regulates it via the tangential unwinder. Depending on the material to be processed, there are two measuring ranges, 10 Newton and 60 Newton. The spiral wire enters the winding head from below, where it is wound around the spiral mandrel. The process speed is set with the drive. Depending on the diameter of the spiral wire, rotational speeds of up to 7,500 revolutions per minute are possible. Depending on the type of spiral wire used, dimensions and material, and the predetermined spiral dimensions, spiral mandrels with various dimensions can be used. The spiral wire wound around the mandrel through the winding head heads up to the mandrel as a spiral with each rotation. The length of the mandrel passes through the heater to just below the pull-off roller at the top of the machine. All mandrels included with this machine have uniform intakes, making them easily interchangeable. A control panel is located on every machine side, which is only used to perform the machine's basic functions. The spiral passing through the mandrel is fixed in the heater, meaning that the spirals are heated in order to prevent them from twisting or springing back onto the mandrel when leaving it. Ceramic infrared heating elements are located in the two-section heater housing. The control system monitors the temperature in the heater via two thermocouples. The control system adjusts the temperature in the heater where needed. The heater is preheated before the process begins. Once the target temperature has been reached, the winding process can begin. The target temperature must first be set in the process parameters of the respective program. This is described in Chapter 2.4. The heater, which is still in neutral position, is then pneumatically opened, pneumatically pivoted to the spiral mandrel, and closed again in that position. The heater now surrounds the spiral mandrel with the spiral feeding in from below during the winding process. The heater's motion sequence is controlled manually with the buttons on top of the machine. The cooling unit is located above in two-section housing, integrated into the two-part heater housing. The spirals moving up out of the heater are cooled back down in the cooling in order to compress them, and to allow for spirals to be manufactured from thick monofilament. Cooling occurs via the cooling unit installed on the backside of the machine. The driven pull-off roller is located above the upper end of the winding mandrel. Depending on process speed and preset pull-off value, the roller pulls the spiral up from the spiral mandrel, and from there the spiral moves down into the spiral can via a downward-sloping guiding track, slide. The spiral can also be wound 1 to 2 times around the pull-off roller in order to increase the tensile force. Cans are placed behind the spiral machine to collect the spirals as they exit the machine. The size of the plastic piping cans is selected to fit the amount of spirals coming off of a 7 or 10 kilogram coil. The tops of the cans are fitted with slots into which the end of the spirals is hooked. In order to connect a spiral sieve, the spirals are processed directly from the cans. Many spiral machines can be monitored via one control center, server, and programmed via one central touch panel. A few buttons for starting the spindle and operating the heater, separate for each spindle, are located on the machine itself. All remaining functions, in particular the input and monitoring of parameter values, are controlled exclusively via the central touchscreen. The corresponding station, machine with 2 spindles, is chosen in the Start menu. All necessary parameters for this machine, depending on the spiral type to be processed, can now be read separately for each spindle, fixed or changed. All important machine functions, along with the current parameter values, are displayed on the clearly laid out control menu screens in the respective menu areas. Turn on the machine with the main switch located on the side of the control box. Then the machine's internal operating system will boot up. The heater can now also be turned on with a push button in order to use the setup time on the machine for heating. The target temperature must first be set in the process parameters of the respective program. More information you can find in Chapter 2.4. Each machine is displayed with a button on the central touch panel's Start menu. Once the desired machine has been selected, that machine's current actual values are displayed for both spindles. From the window with the actual values, the selected machine can be reached via the Process button on the selection window. The rotating or winding direction for the respective spindle is selected here. Then you can return to the window with the actual values by pressing the Back button. From the window with the actual values, you can reach the parameter window of the selected machine by pressing the Select button. Here you can either enter the individual process parameters according to specifications or make any necessary adjustments during the current process. From the window with the actual values, you can access the parameter window of the selected machine by pressing the Edit button. After selecting a free program slot, in this example it is program slot number 5, an empty parameter window is going to be displayed. Tapping the top yellow data field opens a keyboard window that allows you to enter a program name. For example, it can consist of the monofilament sizes and the name of its material. Then the parameter values for the new program can be entered and confirmed. This is done by pressing a numeric keypad which appears by tapping the corresponding data field. Creating or modifying a program is only possible when the machine is stopped. According to the planned process, different procedures are required when setting up and programming. The respective sequences are described in the following steps. The initial situation is the following. Machine is switched off, no coil is mounted. Switch on the machine at the main switch. The machine control will now start up automatically. Now turn on the heater. Please note that for this machine, a program with the corresponding heating parameters must be selected, as it is shown in 2.4. Prepare the following tools: scissors, long, 3mm and 6mm Allen keys, hook wrench, hand gloves, calipers. Place spiral cans behind the machine and select size according to the expected spiral quantity. This procedure is only necessary for changing the spiral size or monofilament. A long 3mm and 6mm Allen key is required for changing the spiral mandrel. Loose the screws on the front cover of the winding head with the 6mm Allen key. The housing half can now be removed at the front and set aside. The mandrel is then rotated such that two magnets are visible on the right side between the narrow side of the mandrel and the housing. The angle should be around 45 degrees. Now it's time to make a color marking. The color marking ensures the correct positioning of the mandrel and helps to avoid problems during the working process. Now remove the two clamping screws located on the hub of the winding head opposite one another for the mandrel intake with a 3mm Allen key. After the previous step, you can pull up the intake. After loosening the clamping screws with the 3mm Allen key, the mandrel can be removed from the intake. To insert the new mandrel, follow the reverse order of this process. When doing so, screw both the clamping screws back in and pay attention that the mandrel is positioned perfectly in the intake. When inserting into the intake, the narrow side of the mandrel must again face the marking. Then insert the mandrel intake with the newly mounted mandrel back into the winding head, and tighten the screws on the winding head firmly again. The two covers of the winding head can now be remounted. It should be noted that the alignment of the marking for the mandrel is the same as the position for disassembly. If the mandrel is twisted, it will be in the wrong position when closing the heater, which will prevent it from closing correctly. Make sure that the screws are tightened. Now check the correct adjustment of the intake via a test run. If the winding head is too high, the spiral wire will rub against the magnets during the winding process and tear. If it is too low, the winding point on the mandrel will be incorrect, and the desired dimension of the spiral cannot be reached. If it becomes necessary to correct the height, the intake must again be removed from the winding head, and the height must be readjusted on the adjusting screw. The spiral mandrel is typically only adjusted when a new mandrel is used for the first time, or when a different spiral size is required. The spiral mandrel essentially consists of two parts, the mandrel itself and the head. The mandrel can be moved up and down in the head and is locked into position with two threaded pins using an Allen screw. From the side view, the mandrel can be divided into three areas: base, conic area, guiding area. The height adjustability allows the spiral wire, which feeds onto the mandrel during the winding process, to hit a specific location on the mandrel during the winding process, the ideal winding point. If the point at which the spiral wire meets the mandrel is too high or too low on the mandrel, the resulting spiral will have irregularities or the thread could snap. For round profiles, the mandrel is fixed in the head such that approximately 8 to 10 mm of the mandrel base is visible as a feed area. The exact dimensions of the feed area have to be verified or determined via a test run. The winding point here is on the bottom end of the feeding area, just above the head. Check if the coil and coil intake are clean. Place the coil on the tangential unwinder, paying attention to the withdrawal direction. Secure the coil with the driving pin. Now place the flange in front on the shaft and in the coil. Stick the clamping cone onto the shaft and push until it stops against the front flange, then tighten. Connect the connection cable of the tangential unwinder to the machine. Now slide the tangential unwinder to the machine with the appropriate angle, and finally fix the brakes of the wheels. Use scissors to cut the knot of the thread on the coil. Pull the thread from the coil and through the front deflection roller in the direction of the two guide pins. Guide the thread through the two deflecting pins towards the second deflection roller. From there on, guide it further down to the third deflection roller. The thread is guided through the third deflection roller. This location is the transition from the tangential unwinder to the machine, diagonally to the fourth deflection roller. The thread is pulled through the fourth deflection roller to the preheater. In order to facilitate the thread's exit, the lid of the preheater can be loosened with a thumb screw and removed. Please note, the thread must also be guided through the lid, then retighten the thumb screw. After the thread has exited the preheater, it is guided over the thread tension sensor roller to the winding head. Push the thread through until it comes out of the winding head at the top. The thread is now knotted at the spiral mandrel. You must pay attention to the winding direction again. Now place the thread, depending on the material or spiral, on the respective thread tension sensor. The machine itself is now ready for the winding process. Now the manufacturing parameters, according to the spiral type and size, via central touchscreen, are set on the controls. Selecting the machine. In this example, it is machine 10. Press the button Station 10. Current actual values for both spindles of the selected machines are on display now. Now press on the Process button. That is how you reach the pre-selection menu of the machine. The rotation direction, left or right, can be set with the left and right buttons for the corresponding spindle. The values shown in the number fields are only for informational purposes. They cannot be changed. Use the button Back to return to the actual values display. Press the Edit button to reach the input window for the process parameters. Depending on the type and size of the spiral, default values including cooling temperature, heater temperature, above or below, preheater temperature, spindle rotation speed, brake and pull-off can be selected here. Inputs and changes can be made via the numeric keypad, which appears after typing on the corresponding display field. Entered values are accepted via the E-Entry button. Once the heater has reached the target value, the spindle can be started by pressing the green Start button on the top of the machine. When the spindle starts running, the tied spiral wire must be secured with 2 fingers during the first rotation to prevent it from winding onto the mandrel. Open the heater while the spiral is in the upper position. Now swing the heater to the mandrel. During the startup phase, the wound spirals, as needed according to spiral type, must be lightly pushed up onto the mandrel by hand to avoid tangling and a resulting tear in the thread. Then the spiral must move upward on the mandrel by itself. If this is not the case, then the process parameter is not correct. As soon as the wound spiral reaches the upper end of the mandrel, it is placed on the guiding track via the pull-off roller, and the heater is closed by pressing the corresponding button once the desired speed has been reached. The dimensions of the spirals must be regularly checked during the first few minutes of the winding process. If needed, the process parameters must be corrected. The spirals, which are wound until the desired dimensions are reached, are not suitable for sieve production. Once the desired size has been reached, the spirals are guided to the provided cans. At this point, measurements in half-hour intervals are sufficient. 1-hour intervals if the machine is warmed up. The winding process runs automatically. If a disturbance occurs, for example a thread tear, or the coil is empty, the machine will shut off automatically. The red light on the spiral guiding arm will illuminate, and an acoustic signal can be activated. When turning the machine off, the heater is automatically opened and then turned into inactive position. Definition of spiral dimensions. L equals length of spiral, T equals thickness of spiral. Size L too large, thread tension too low. Increase process parameter brake for PET in intervals of 0.5 newtons, for PPS in intervals of 0.2 to 0.3 newtons. Size L too small, thread tension too high. Reduce process parameter brake for PET in intervals of 0.5 newtons, for PPS in intervals of 0.2 to 0.3 newtons. Size T too large. Heater temperature too high. Reduce process parameter temperature above or below in intervals of 5 degrees centigrade. Size T too small. Heater temperature too low. Increase process parameter temperature above or below in intervals of 5 degrees centigrade. Spiral shape irregularities. Mandrel not properly positioned. Too high or too low. Readjust mandrel. Thread tension too low. Increase process parameter brake. Temperature too high. Adjust properly process parameter temperature above or below. One small and one large calibrating weight with approximately 5,000 grams or 500 grams and a hook at the top are needed for calibrating the thread tension sensors. The 500 gram weight is for calibrating the 10 Newton sensors, and the 5,000 gram weight is for the 60 Newton sensors. The Spiralmachine's selection window can be found above the service button located at the bottom of the touch screen. Select the desired machine by pressing the corresponding button. This will open a window in which all further steps are processed as described below. The exact weight of the small and large calibration weights must first be determined and entered into the data fields. The values labelled thread tension 1 refer to the 10 Newton sensor, and thread tension 2 refers to the 60 Newton sensor. For unloaded sensors, the 0 values, not equal to 0, are initially determined in the controls. By pressing the button 0 point, the value displayed in the corresponding data field is transferred to the left side of the display. The values for the other sensors are now recorded sequentially in the same way. In the white data field on the right side of the 10 Newton sensor currently loaded with the calibration weight, its weight value is now displayed. This value does not correspond with the weight of the calibrating weight in grams. By pressing the Calibrate button, the value displayed on the right is transferred to the blue data field on the left. Now the weight can be replaced by the large test weight, and the spiral wire can be guided outside over the roller of the 60 Newton sensor. Pull the spiral wire like described in the chapter Feeding the Monofilament into the Machine and tie it to the spiral mandrel. Take the spiral wire between the 4th deflection roller and the tangential unwinder and feed it over the deflection roller mounted under the machine tabletop. Now the spiral wire on the tangential unwinder is cut off about 50 centimeters below the deflection roller and knotted into a loop. First, the 10 Newton sensor is calibrated with the smaller weight. The weight is also hung in the prepared knot in the spiral wire. The spiral wire must now rest on the outside of the roll of the sensor. The weight must not swing during calibration, because if it does, no single value will be available as a basis. First, the corresponding machine is selected in the controls in the service window. In the window Service Station 10, the target values and the actual values of both sensors are displayed accordingly on the left and on the right for each spindle. In the white data field on the right side of the 10 Newton sensor currently loaded with the calibration weight, its weight value is now displayed. This value does not correspond with the weight of the calibrating weight in grams. By pressing the Calibrate button, the value displayed on the right is transferred to the blue data field on the left. Now the weight can be replaced by the large test weight, and the spiral wire can be guided outside over the roller of the 60 Newton sensor. The second sensor is now calibrated in the same manner. In order to ensure error-free operation, the following cleaning work has to be done at least weekly. Clean, if necessary, the coil clamping rings in the tangential unwinder, the deflection rollers, the guide rollers on the thread tension sensor, and the interior of the machine. To clean the winding head, open the winding head and pull off the front and rear covers. Then clean the thread guide channels with acetone. The acetone has to be injected with a syringe into the thread outlet. Keep acetone about 1 hour in the winding head before blowing out. Keep a cleaning cloth pressed against the head on the bottom end. Ensure that no acetone drops on the sensors. In order to ensure error-free operation and machine safety, a few maintenance operations must be performed regularly. Check the drive belts and belt tension, guide rollers on the thread tension sensor, deflection rollers, as well as spiral cooling. Check the coolant level in the storage tank, and if needed, top up with water biocide mixture.